Hi everybody. So we're going to just take a couple of minutes and review a couple of problems from yesterday. This was not on your homework, but I did want to just go over the concepts to make sure we're all on the same page. So 4 is to 36 as W is to 9. So I'm going to use a mental math strategy. I'm going to look for a relationship between numbers. I know that if I multiply 9 times 4, I'll end up getting 36. Well, that tells me that if I multiply W times 4, I'll end up getting 4. So what number can I multiply times 4? In other words, I'm saying W times 4 equals 4. What does W equal? That's right, 1. So a lot of these you can just do in your head, but not always. Sometimes you're going to need to use algebra. Number 16 is a great example of that. Here I have K is to 27. As 4 is to 6. So the first thing I want to point out is that you can isolate, or you can look at this question as K divided by 27. And if this was algebra, if you put on your algebra hat, you're going to say, oh, I want to isolate that variable. And how I isolate that variable is I multiply it by 27. That's going to end up being 27K divided by 27, which is K, aka those kind of eliminate each other. So I'm just left with K. But if I multiply by 27 on one side, I have to multiply by 27 on the other side. And so that leaves me with 24 times 27. Well, fortunately, you guys get to use calculators on this one. So 4 times 27 equals 108. But I'm not done because I still have 6 as a denominator. That's a division problem. Divided by 6 equals 18. So K equals 18. So I can use two methods to solve this type of proportional problem. So getting into 8.5 today, we're going to be looking on page 423 for 8.5. So 8.5 is solving proportions using cross products. And if you're following along, I'm on page 423. So the cross product property states that the cross products of a proportion are equal. So let's take a look at an example here. So 3/4 is equal to 15/20. So again, the cross products, I'm going diagonally, cross products are equal. Now the word product means, hopefully you said multiply. And so if I multiply 4 times 15, and then I multiply 3 times 20, my cross products, these numbers should be equal. And guess what? They are. 4 times 15 is 60, and 3 times 20 is also 60. And so you're probably saying to me, well, yeah, I guess that makes sense. That's not too crazy, right? So how do you solve a proportion using cross products? Well, you're going to use a cross product, and then you're going to use algebra. So let's take a look at example number 1. In example number 1, we have 2 is to 9 as 3 is to D. So we're going to use the cross products property to solve this. So first, let's use the cross products property to multiply. So I'm going to have 2D is equal to 9 times 3, or 27. 2D is equal to 27. Just how I got there is 2 times D, 2D, 9 times 3, 27. So now what I'm going to do, well, this looks again like algebra. That's not the end of the world. I know that I need to isolate the variable and just divide by 2. Divide by 2, and I'm going to end up with D equals 13.5. If you didn't know what 27 divided by 2 is, you have a handy-dandy calculator that you can use. So there it is. Pretty straightforward. let's do one problem from the guided practice together here. So I'm on guided practice problem number 1 and guided practice number 1. And this is b is to 10 as 3 is to 4. So I'm going to use the cross products property, multiply diagonally. 3 times 10 is 30, and 4 times b is 4b. Now you might be asking me, does it matter which one goes on which side? Not really. You could solve it either way. You could write it as 30 equals 4b, or you could write it as 4b equals 30. You tell me, does it change it at all? Probably not. Let's try. How do I find out what b is? Well, you divide by 4. Isolate your variable. Same thing would be here. You divide by 4. Those cancel out, and I have b. And 30 divided by 4 is 7.5. Just like here, 30 divided by 4 is 7.5. So that's one way to solve a proportion using cross products. So writing and solving a proportion, this is when we're going to get a little bit tricky. So now you're going to be reading word problems, and you have to look for proportions. So let me pull up the book and just kind of zoom in on example 2 on page 424 and kind of talk through it together. Page 424, example 2 is what we're going to be looking in here. And I'll zoom it in. All right. Okay, so example 2 says, to find the weight W of a 60-pound dog on the moon, as described on page 423, write and solve a proportion using the weight of the person. Oh man, I think I'm going to have to go back and read something. Yeah, so let's take a look. So a person who weighs 105 pounds on Earth would weigh 17.5 pounds on the moon. So about how much would a 60-pound dog weigh on the moon? Well, you can use cross products. So a person who weighs 105 pounds would weigh 17.5 pounds on the moon. So it looks like we're doing a proportion of weight on Earth to weight on the moon. So weight on Earth of a 60-pound dog. So let's go back to our problem here. Yep, that's exactly what we're doing. Here I have my proportion of weight on Earth to weight on the moon. 105 pounds on Earth to 17.5 pounds on the moon. Oh wow, I'm really light on the moon. Okay, so to solve it, so first off, you use cross products property. You multiply diagonally. 17.5 times 60 is, and then you'll have W times 105, which is 105W. You divide by both sides by 105, and you're going to end up with 10. So a 60-pound dog would weigh about 10 pounds on the moon. So let's do an example of that. Let's do number 4, which is the guided practice number 4 at the bottom of that page. And guided practice number 4 says, in example 2, suppose that a 150-pound astronaut stood on the moon. How much would that astronaut weigh? So number 4, I need to remember what my original proportion was. 105 pounds on Earth to 17.5 pounds on the moon. So let's go, we want to know what 150 pounds on Earth is. What is the weight on the moon? So I can make this any variable. Here, I'm going to make it x. Same thing, cross products, multiply and multiply. So get my calculator out. Here we go. First up, well, I know 105x because 105 times x. 105x. And then 17.5 times 150 is going to equal 2,625. All right, so now I'm faced with this algebra problem. 105x is equal to 2,625. And so if you said, isolate the variable, Mr. Canapeel, get x by itself, you are correct. Divide by 5. Divide by 105. That gets rid of that, and I'm left with x. And guess what? 2,625 divided by 105 equals 25. So the answer, I got to go back to my question. How much would he weigh on the moon? I'm not done. 25 pounds on the moon. All right, so the last problem here is multi-step problems. In the multi-step problem, we're facing a little bit more. So I'm going to go back to the book in example 3. So just to review, we've now looked at examples of how to solve proportions using cross products. That was pretty straightforward. After that, we looked at writing and solving a proportion. Now we're going to look at how you can solve a multi-step problem. Okay. So let's start by reading. Penguins. There's 50 penguins at an aquarium. The ratio of rockhopper penguins to African penguins is 3:7. How many are rockhoppers? All right, well, let's find out what the ratio of rockhoppers to total penguins is. So remember that the ratio of rockhoppers to Africans is 3:7. So that means for every 3 rockhoppers, there's 7 African penguins. But 3 plus 7 would equal 10 penguins. And I can figure that out by adding the number of rockhoppers and the number of African penguins. So there's a total of 10 penguins. So that's the tricky first step, is to find out what the ratio is of one thing to the entire set. Okay, step 2, now we're facing a little bit more of a challenge. Now we have to solve. So let's write and solve a proportion to find the number of R rockhoppers. So 3 to every 10 as R is to 50. I know that there's 50 penguins because it states it right there. And I'm trying to find out what rockhoppers are. That's my variable. And so cross product. That's right, you got it. 10R is equal to 150. You divide by 10 on both sides. Divide by 10 on both sides, and you end up with 15. And you answer your question as, there are 15 rockhoppers at the aquarium. So let's look at an example. These ones are definitely tricky for sure. And I want to do one last example to make sure that we're all on the same page. So this is going to be a multi-step problem as well. If I can find some paper. Here we go. So let's get to it. So I'm going to do guided practice number 6 at the bottom of page 424. So this is guided practice number 6. So it says the ratio of tubes of acrylic paint to tubes of oil paint in an art teacher's supply cabinet is 3:2. So 3 acrylic paints to 2 oil paints. So if that's my ratio, how many would I have total? I'm going to add them up, and I would have, 5 paints total. And so my ratio for paints is, for acrylic would be 3 to every 5 is equal to, now it tells me that there's a total number of paints. It says that there are 65 tubes of paint. Total is 65. So how many are acrylic? There's my ratio. Then this is the ratio to represent the acrylic to total number of paints. Multi-step. This is step 1. You have to find your original ratio and your original ratio and proportion. Then you can compare it to what you have total. Remember, this right here is the total number of paints. So that includes all of the acrylic and oil base. So I finally got to my proportion, 3 is to 5 is A is to 65. Cross product time. So I've got 5A equals 3 times 65. I think that's 205, 195, 195, 195. Time to solve for A. Divide by 5. Divide by 5. And guess what, folks? That cancels out. 195 divided by 5 equals 39. So there's 39 acrylic paints total. So there you have it. So these are challenging for sure. Homework is on plus portals. Again, I'm just going to hold another Zoom, optional Zoom. If any of this is getting a little complicated for you, please join me. I will be available. Thank you.